NASA has been very interested in planet Mars and has sent multiple rovers to explore the terrain. As somebody planning to set up a permanent outpost on the planet, Elon Musk has been paying attention to all the discoveries NASA's rovers have made. The latest rover to land on Mars is the Perseverance, accompanied by a small helicopter named Ingenuity. What has NASA's Perseverance discovered on Mars, and how can the discoveries affect you? Stay tuned as we bring you the shocking findings Elon Musk and NASA just made on Mars that shock the entire space industry. While you watch this video, there is an autonomous vehicle trudging along millions of miles away on planet Mars. Its name is Perseverance, and it costs a cool $2.7 billion, much more than any vehicle you might see on the road today. Why did NASA spend so much on Perseverance? For years, NASA's Mars exploration program has been systematically trying to find out whether life ever existed on Mars. The agency's Spirit and Opportunity rovers showed that liquid water once existed on the surface. Building on that discovery, NASA's Curiosity rover found conditions on Mars around 4 billion years ago that could have supported life as we know it. Now Perseverance will directly search for signs of past life. Perseverance launched on July 30, 2020, amidst the challenges and chaos of the global COVID-19 pandemic. It landed on February 18, 2021 in the Jezero crater, the site of an ancient lake and river delta, during 7 minutes of terror, as mission controllers could not direct the process in real time. At the crater, the rover will search for microbial fossils in rocks formed in Mars's warm, wet past. We'll also look for carbon-containing molecules called organics that form the building blocks of life on Earth. Not since 1976 has NASA directly searched for life on Mars, when the dual Viking landers performed long-shot chemistry experiments that turned up inconclusive results. Perseverance collects soil and rock samples as it travels and stores them in tubes that future missions by NASA and the European Space Agency will collect. Despite technological advances in making small, low-power science instruments for space missions, many types of laboratory analyses still can't be performed in space or can't be done very precisely. Additionally, science is all about being able to reproduce results. Getting Perseverance's samples back to Earth means we could run the same science experiments in multiple laboratories. What does Perseverance look like? It is a 1-ton, 6-wheeled Mars rover the size of a compact car. It has the same design as the nuclear-powered Curiosity. Perseverance can operate through dust storms that block sunlight required by solar-powered spacecraft. To land, Perseverance improved upon the complex 7-minute landing sequence referred to as the 7 minutes of terror. The landing used a supersonic parachute, a thruster-powered descent, and nylon cords that lowered Perseverance the final few meters to the surface. Using images from navigation cameras placed strategically around the rover and imagery from orbital satellites such as NASA's Mars Reconnaissance Orbiter, scientists and mission operators work together to drive Perseverance to promising areas. Perseverance will investigate any spot that looks interesting, collect a sample, seal it in a small tube, and deposit the tube on the surface for a pickup to Earth. Perseverance is equipped with life-scanning tools, including 2 Raman spectrometers. These are science instruments that shine ultraviolet light on a rock or soil patch and read the reflected light signature to determine what chemical compounds are present. Perseverance has one on its robotic arm named Sherlock and another inside SuperCam, an instrument at the top of the rover's mast that contains a laser to zap rocks several meters away. Perseverance also has a camera mounted to its robotic arm to see features as small as a grain of salt. At the rover's lower rear is RIMFAX, a radar that can detect pockets of water up to 10 meters beneath the surface. Also aboard Perseverance is a weather station called MEDA and MOXIE, a car battery-sized device that will extract carbon dioxide from Mars's atmosphere and produce oxygen. MOXIE will demonstrate the feasibility of manufacturing oxygen on Mars for future astronauts to breathe and use as rocket fuel. Musk will pay attention to this part as he needs to find a way for his Mars explorers to breathe oxygen. The Perseverance rover is accompanied by a small helicopter named Ingenuity. The helicopter has no direct impact on Perseverance's mission, but it will help NASA learn how flying machines can work on the Red Planet. Since landing, Perseverance has been busy with its cameras. There are 23 cameras on the rover, and they have returned over 100,000 images of the Red Planet. These photos are already helping us understand how the landscape was shaped by water and provide clues that will guide the search for ancient microbial life. NASA has made the raw images available to everyone, and you can view them in an online gallery. The photos include an iconic selfie with Ingenuity. Ingenuity itself has flown at least 19 times, the first being on April 19, 2021. It was the first time a powered flight had taken off on another planet. Ingenuity is equipped with two cameras, a forward-facing 13-megapixel color camera with stereoscopic imaging capabilities, and a downward-facing black-and-white navigation camera. With these cameras, Ingenuity provides high-resolution images, but it is also creating a high-fidelity 3D map of the Martian topography, the type of 3D image that jumps from the page when you wear those fetching red and blue glasses. Perseverance, however, has done something more exciting. In fact, this next achievement can change the face of space exploration forever. In another first for this mission, the gold car battery-sized instrument made history when it created oxygen from the carbon dioxide in the thin Martian atmosphere. In other words, MOXIE will help provide humans with breathable air and come home safely. Using solid oxide electrolysis, MOXIE works by drawing in carbon dioxide from the atmosphere, compressing and filtering it to remove contaminants, then heating it to separate the oxygen and carbon monoxide. The carbon monoxide is expelled back into the atmosphere, while the oxygen is isolated by a hot, charged ceramic component, causing the oxygen ions to merge into the precious oxygen. MOXIE generated about 5.4 grams of 98% pure oxygen in 1 hour. For context, this is enough oxygen for a human to breathe for about 10 minutes. The process takes a huge amount of energy and is limited by the power supply to 12 grams per hour, around the same as a large tree makes. Scientists hope that when scaled up to around 100 times larger, this technology may be used to not only provide breathable air for future explorers, but also as a propellant to lift astronauts off the surface. You may recall at this point that Musk plans to produce propellant to power the Starship right on Mars. Perseverance has also been busy collecting samples. The rover has taken 6 samples of the Martian rock and atmosphere, while scientists back home eagerly anticipate and plan for their return. Perseverance also drilled 6 centimeters into the Martian surface and extracted a rock core, carefully sealing it in a tube. That was the first time a spacecraft had ever taken samples from another planet that could eventually be returned to Earth. When the samples are delivered, scientists can analyze them using technologies that may be impossible to transport to Mars. Apart from collecting samples, Perseverance has made another important confirmation on Mars. Thanks to the rover, scientists have analyzed one of the crater's most massive geological features, the Delta Scarp. They have confirmed that the Jezero crater, a dry, wind-eroded depression today, was once an ancient lake fed steadily by a 120-mile-long river around 3.7 billion years ago. As further proof, the crater also contains a triangular-shaped delta where the river once fed into the lake. There are chances that the river delta was mostly calm, but there is evidence of high-energy flooding in the area, transforming the slow, meandering waterway into fast-moving flash floods. Perhaps caused by a dramatic shift in climate, these waters were strong enough to carry large boulders downstream before depositing them in the lake bed. Now that Perseverance has confirmed the landing area was once a lake environment, we may find evidence of ancient aqueous life in the underlying sediments. But that is not all that Perseverance has discovered in its short stay on the planet. It has also discovered organic molecules. Carbon-containing organic chemicals have been discovered in some of the rocks in the Jezero crater by the Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals instrument. The molecules containing the carbon have been found in both the interior of abraded rocks and in the dust of non-abraded rock. However, scientists cannot yet say with certainty that there has ever been life on Mars. That conclusion will require more rigorous tests, but we might move closer to the discovery when the samples arrive on Earth. Let's hear what you think of NASA's discoveries on Mars in the comments section below.